Hi learners, today we will be discussing about a very important topic in postgraduate certificate in climate change, that is climate system. This is the foundation for climate science, and when you look at the word climate system, every one of us know that there is a normally we use the word weather and climate. Often people use synonymously, but there is subtle differences. When you look at the word weather, it is basically the state of the atmosphere in a particular place and time, and it deals with the the weather parameters like temperature, humidity, and so on and so forth. Many parameters are there. But as far as the climate is concerned, it is basically the average weather for a particular place, a larger region, and for a longer period of time. This is climate. So average weather is basically called climate. So to start with, this whatever we are experiencing, whether it is a weather or a climate, it is a lot of output. It's kind of a product of a lot of interaction that is taking place in the system. It's a system approach. So let us see what exactly the climate system is. Basically, climate system is a interactive system, a very complex system indeed, and it is basically a product of interaction that is taking place between the atmosphere, the hydrosphere, the biosphere, the land surface or geosphere, and the kind of interaction, the interaction can be the physical, chemical, and biological interactions. So this is about climate system. So basically it is having 5 important components. Each and every component is having its own significance. So look at this picture, and you can see for yourself that what kind of interaction that is taking place within the different systems, subsystems of a climate system. So that when you look at it, each and every system, that is atmosphere, the hydrosphere, the cryosphere, they are all open systems. The subsystems are very open and a lot of interaction. When it is open, then only you can have a lot of interaction. It can be interaction in terms of mass, energy, momentum. So a lot of changes that is taking place between each and every component of the climate system. So the most important component as far as climate system is concerned, you can see for ourselves that it is the atmosphere. And the atmosphere, yes, it is very rich in a lot of gases, particularly the nitrogen and oxygen are predominant as far as the atmospheric gas composition is concerned. Nevertheless, there are few important gases like carbon dioxide, nitrous oxide, ozone, water vapor. They are very kind of minor gases, and in terms of quantity they are very less. That's why they are called as trace gases. Nevertheless, they are very important for the climate system. In fact, they drive the climate system. When I say they drive the climate system, these gases have an important property, a radiative property. So they are in a position to observe the long wave radiations, and this is an important property of the greenhouse gases. Indeed, if you see, the greenhouse gases are those gases which can absorb the radiations more than 4 micrometer. That is a basic thing. So these radiatively active gases are responsible for an important effect called greenhouse effect. This atmosphere, which is very chaotic, not stable, and that is having a lot of interaction between other systems. Let us see what other things. So the next important system is the hydrosphere. Hydrosphere is very important, because when you look at it, the kind of the extent wise, it is very, the ocean body, the freshwater body, even the underground subterranean water body. So everything will be part and parcel of this hydrosphere system, and this hydrosphere system contributes or is linked very well with the atmosphere through a simple process, like evaporation. And that's a key thing, because through hydrological cycle, these atmosphere and hydrosphere system are coupled, and this because of this hydrological cycle, we know fully well that the evaporation process also takes up a lot of energy, that takes up the solar energy. So what happens, because of this evaporative process, the solar, what you call, the solar radiations have been observed, and water will be transforming into a liquid form or a vapor form. So this kind of phase change also involves absorption of radiation, and when it is condensing, the process of precipitation, it releases energy. So latent heat is released. So this evaporation process, the hydrological cycle, is very, very important, because that is how this atmosphere and hydrosphere are very well coupled. And we know fully well that water vapor is a very important greenhouse gas, and of course the concentration varies, and on an average it will be around 1%, 1 to 5%, it will be the concentration of water vapor, but it is a very significant greenhouse gas. Next important system as far as the climate system is concerned, it is the cryosphere. The cryosphere, when I talk about cryosphere, yes, it is the glaciers, the ice sheets, Antarctic, Greenland, the glaciers on the land, continental glaciers, the sea ice. It is a huge mass, cryosphere is a huge mass, and it is having a lot of role to play as far as the climate is concerned, and indeed the climate change. So when you talk about the most important thing, when you see the cryosphere, when you visualize the process called albedo. Albedo means it is having a power to reflect the radiation because of the what you call it's white in color, so it reflects the solar radiation. So the albedo is a very, very important thing, and it plays a very important role. So this cryosphere is also linked with the climate system or in other systems like atmosphere and water body in many ways. And one important thing is, as far as the cryosphere is concerned, because of the increase in temperature, the ice mass, the glaciers present in the continent or the Antarctic, Greenland, they can melt. And because of this melting process, a kind of positive feedback can happen, and that can augment the temperature increase. When I say augment the temperature increase, because of melting of ice, because of melting of glaciers, the albedo value will reduce, and in other words, the solar radiation coming from the sun, it will be absorbed. So that is a key link between the cryosphere and other components. And because of the increase in the the melting process, that is in Greenland or in Antarctic, what happens? There will be increase in the sea level. And because of the increase in the sea level, that will have an impact on the circulation process. That what I mean to say, that the circulation that is taking place within the ocean body, that is thermohaline circulation, that I will discuss later on also, thermohaline circulation. And that thermohaline circulation is significant. Why? Because it carries the heat from the equatorial region to the polar region. And because of this thermohaline circulation, what happened? Ocean body act like a regulator of the climate system, and most of the energy increase or most of the solar radiation, it is captured in the ocean body. That is the reason why it is called it is a regulator of the climate system, because it's having a thermal inertia. When you look at it, it's a large thermal inertia, and it is doing the best possible thing because of that reason. Similar is the case the cryosphere. So these are the three important systems, and the fourth one is the land surface, the geosphere. And land surface, the vegetation, the soil, these also play an important role. Let us see how it is. So when you look at the soil, the soil moisture also can contribute in regulating the surface air temperature. How? Because of the soil moisture, because of the evaporative process, that also, because evaporation it requires a lot of energy, it consumes energy, and because of that thing, that will influence the surface air temperature. So soil is a very important thing. Next one is the vegetation. When you talk about the vegetation, again the vegetation or the soil, it talks about what? It reflects about the texture, it reflects about the roughness of the land surface, and the topography, and this topography also will influence the circulation pattern, atmospheric circulation. So atmospheric circulation is equally important like your ocean circulation. I am talking about the thermo-alien circulation, and this atmospheric circulation is why is important, because it carries the energy and kind of a budgeting, like kind of balance that is existing in the global, the earth surface is because of this circulation pattern, atmospheric circulation or ocean circulation. So that atmospheric circulation will be influenced by the topography of the land. So that is how this land surface is also a very important component of the climate system. Next one is the biosphere. Biosphere means the living organisms, whether it is on the earth surface, land surface, or on the ocean body also, the marine biota. So these biospheric plays a pivotal role as far as regulating the climate. It regulates the climate system as well. So the very basic thing is the process called photosynthetic process. And the photosynthetic process is the most important process as far as the when you look at the past history of the earth. Because of the photosynthetic process, the concentration of the carbon dioxide, the concentration of oxygen in the atmosphere has been regulated, and in that sense the photosynthetic process is very, very significant. Why? Because because of this photosynthetic process, the vegetation, the biomass, the growth of the organisms, they are in a position to capture the carbon dioxide. They are in the position to sequester the carbon from the atmosphere in the form of carbon dioxide. And photosynthetic synthesis is a very important process, because a lot of potential is there as far as the mitigation is concerned. A lot of potential is there to capture the carbon dioxide from the atmosphere, and that is how this biosphere also plays a significant role in the climate system. When you look at the other aspect, because the carbon dioxide is a most important link between biosphere and the atmosphere, the other process also, evapotranspiration, is also equally important as far as the link, as far as the coupling between the atmosphere and the biosphere. So that is the thing we need to understand as far as the the climate system is concerned. And as far as the atmosphere is concerned, if you see, there are certain other important things that is happening. The condensation process, the clouds, they also, in the atmosphere system, they also play a pivotal role as far as the balancing, as far as the interaction, that is the physical, chemical, biological interaction that is taking place in this climate system is also influenced by the clouds. So this is all about the climate system. Now let us go for an in-depth analysis of what exactly, what drives the climate system. When you look at the driving mechanism, the energy we are getting, the earth surface is getting, is the main source is solar energy. Almost 99% of whatever the energy the earth surface is receiving, it's from the solar energy. Sun is an important energy source. Nevertheless, the terrestrial bodies also, radioactive materials present deep inside the earth surface also contributes energy to the climate system. So both are equally important, but 99% of energy that is we are receiving from the sun, that is the most important resource or source as far as energy resource is concerned. And this solar energy, when it is reaching the earth surface, in a lot of interaction that is taking place. The solar radiation interacts with the earth surface, it interacts with the atmosphere, and a lot of interaction is taking place. But when you look at it, the solar output, the sun energy, that is also influenced by many factors. The solar activity is important. The distance between earth and sun is important. The altitude of sun is important. And length of the day, that is also important. So there are many factors that are influencing the solar output. Nevertheless, the solar output, if you look at it generically, if you look at it in terms of the wavelength, almost 40% of the solar radiation is in the bandwidth of visible range, and almost 50% is in the bandwidth of the thermal radiation or infrared radiation. Very meager amount, that is around 7% is in the terms of ultraviolet radiation, very short wave radiations, which is very in fact dangerous indeed. The ultraviolet radiation, and that ultraviolet radiation, which is very rich in energy, that is absorbed by a layer in the atmosphere that is called ozonosphere, that every one of us know that thing. But technically what we wanted to say is that the solar output is also influenced by many factors. Nevertheless, we can have a constant, we call this a solar constant. It's around 342 watts per meter square on a spherical Earth surface. If you see on an average, it is 342 watts per meter square. It is a solar constant. Of course, it varies. The solar constant also varies around to an extent of 0.1% because of the activity, solar activity. That's called, the very possible one is the sunspot cycle. Even that less than 1%, but that 1% also is having a lot of repercussion. It can cause a change in the temperature, surface temperature, to a tune of 0.1 degrees centigrade. That itself is a very major amount. That's what I wanted to stress at this point of time. So this energy, that is the solar energy reaching on the top of the atmosphere, that is that's what we say, top of a TOA, top of atmosphere, 342 watts per meter square, and almost 31% of this energy reaching on the top of the atmosphere is reflected back. That is called as albedo. So remaining amount, it reaches the Earth's surface, it interacts with the atmosphere, and the process it gets absorbed as well. And once it is reaching the atmosphere or absorbed in the atmosphere, and the same is the case with the Earth's surface, it has to go back. So when it has to maintain the balance between incoming solar radiation and outgoing the terrestrial radiation. There should be a balance, and this balance is required for stable climate. So for around 235 watts per meter square, that has to be emitted back into the atmosphere, to the outer space, then only the stability can be maintained. And for this to happen, so 235 watts per meter square is absorbed by the atmosphere or the Earth's surface, and this has to go back into the atmosphere. So this balance has to be taken, then only we can have a stable climate. And for this to happen, the Earth's effective temperature should be minus 19 degrees centigrade. Minus 19 degrees centigrade. But now what's the temperature? The average the global surface air temperature is around 15 degrees centigrade. Yes. So there is a difference of 33 degrees centigrade. And the difference of 33 degrees centigrade, why it is? And that is because of the radiative property of atmosphere. A lot of interaction, a lot of circulation process, atmospheric circulation or ozone circulation, it is taking place. And this 33 degrees centigrade is because of an effect called greenhouse effect. And that is made possible by certain group of gases present in the atmosphere. They are called as radiatively active gases, which has the power to absorb the radiation at certain wavelengths. The water vapor, the carbon dioxide, the ozone, the methane, nitrous oxide, these are all the gases present in the atmosphere. They are having the ability to absorb the long wave radiation. So as I told earlier also, these gases can absorb the radiation more than 4 micrometer. That is, these gases are called as radiatively active gases, and because of this reason only we have greenhouse effect, and because of greenhouse effect only the average surface air temperature is 15 degrees centigrade, otherwise it would have been minus 19 degrees centigrade. And this temperature, that is 15 degrees centigrade, is because of that thing we are living, the life is existing. And that is why the lot of positive repercussion is there as far as greenhouse effect is concerned. But if the trace gases, if the greenhouse gases, the concentration changes due to certain activities, whether it is a natural activity or a human activity, then there is a problem, and that problem will be in terms of changes in the atmosphere, temperature, the surface temperature, that we called as climate change. This is about in simplistic terms, this is about the energy budget and the climate system. So now let us go into the term climate change. So we have seen the climate system, the interaction that is taking place in the subsystems of the climate, and let us see what is climate change. We have seen climate also. It's a change. So technically it has been defined as a change in the state of the climate that can be identified by changes in the mean and or the variability of its properties, and that persists for a longer period of time. And this change it's in terms of any parameter, meteorological parameter, The most common metric is the temperature. Temperature is the most common metric. We can measure it, and I'm talking about the instruments are there to are available to measure the temperature. So that is a basic and common metric we use it for understanding climate change. And this change has to take place for a longer period of time. World Meteorological Organization has stated that the change should be for a period of 30 years and more, and then only we can call it as a climate change. This is the technical definition given by the IPCC and other international bodies. Linked to the climate change is the variability concept, and that is called climate variability. In fact, variability is more important than the change, because the kind of the extreme events that we are experiencing, it's more dangerous. We are unable to predict it. So that climate variability is equally important like your climate change. So what we need to do is that take into account is that both variability, climate variability and climate change, is the most important thing that we need to take into account as far as the mitigation, how it is, the causes of it, and how to manage it. So everything will be covering in this particular program. And now look at the definition of climate variability. The variability is the variation in the mean state of the atmosphere as a statistics. Basically, when you look at the statistics, we normally use the word the mean, the standard deviation. I'll explain to you the variance and everything, how these statistical measures will help us to understand the concept of variability. And this variability can occur in a larger spatial extent, and also the temporal scales also. So this is about the climate variability. Okay. Now, I'll explain to you through this particular graph. We have a data, meteorological data, the time series data. For a longer period of time we have it. If it is stable, if it is static, or another, what means that the responses for a certain period of time will not be changing, then only we can call it as a static. Okay. So that particular data, meteorological data, if you start plotting it, say for instance the temperature, you can plot it, you will be getting a bell-shaped curve. Okay, for yourself, you can see for yourself, it's a bell-shaped curve. The top, the peak of the bell, that we call it as mean, and the limbs of the bell-shaped curve is the variance. Okay, assume that if climate is changing, if there is an increase in the temperature, increase in the mean value, so then what happened? The bell-shaped curve will move towards your right side, and because of this reason, the occurrence of cold weather, that will decrease, but the hot weather, events, I'm talking about the extreme event, that all will increase, and this is called as climate change. So the mean is increasing, and because of the increase in the mean value, that is the temperature, the bell-shaped curve moves towards your right side, and because of that reason, the hot weather occurrences, that is increasing. This is basically about climate change. Look at this one. This slide talks about the variance. I just told about the the limb of the bell-shaped curve. The limb, it's called variance. It's called variance, and if somehow the bell-shaped curve gets flattened, and if it is flattened, I mean to say that the variance is increasing. You look at the arrow mark, red color arrow mark, it is flattening, and because of the flattening, the variance is increasing. And when variance is increasing, what it means? The extreme events, whether it's a cold event or a hot weather event, that will increase. Okay, this is about variance, variability, variance. So now, if both are occurring simultaneously, what will happen? There is increase in the mean value. Along with that thing, the variance is also increasing. So this is what is happening now. Climate is changing and variability is also increasing. And this case, what will happen? You will be finding more of extreme events. That is also an indicator of what? Climate change. Extreme events like even in the drought, flood, the typhoons, the cyclones, so on and so forth. So the frequency of occurrence, the quantity of rainfall, the precipitation, everything is varying, and that is how it is extreme. Okay, so this is about the climate system, the energy budget, and what exactly the meaning of climate change and variability. Now let us see what are the causes, what is driving the climate, what is that driving. So the most important thing is that as far as the drivers are concerned, there are many natural drivers. Human beings came much later. Their actions, their activities, their use of fossil fuels, it has come later, much later. Now the present population is around 7.2 billion. Earlier, 3-4 centuries back, it was less. So what it was there all along was the natural drivers. So these natural drivers also was responsible for causing a lot of climate change. That is how you see in the past you will be finding a lot of glacial epochs, ice ages you would have seen it. And this geological history, when you look at the geological history, is because of the natural reasons. And let us see what are the natural drivers. As I told you that the first and foremost important thing is the variability. The variability in terms of the solar output. We have seen even the 11-year cycle, the sunspot cycle, that also can influence the solar output. The similar fashion, the solar output has changed, and that I said very rightly that the solar output, the distance between the earth and the sun and the length of the day, these are all the factors that is responsible for influencing the solar output and the energy reaching the earth's surface. So the first and foremost important thing as per the natural drivers is concerned, the solar system, not solar system, solar output, and that is external to the system, external forcing agent. The second one is the variation that is taking place in the orbit, orbital variation. When you look at the orbital variation, is very interesting because how Earth revolves around the sun and what orbit, whether it is the eccentricity, that is most important thing, because because of this eccentricity, the Earth revolves around the sun, and the eccentricity can vary between the circular to the elliptical orbit, and because of this variation, the climate can change. And this variation occurs, it's recorded indeed, it is associated with the 1 lakh years. And the similar is the case with the tilt angle, that's called tilt angle, and that's called obliquity. That means that if you see the Earth's axis is a little bit tilted, now it is 23.5 degree, degree it has been tilted, the Earth's axis. That can vary between 21.5 to 24.5, and this is also a very important thing, and that can also cause a lot of changes in the climate, and that is associated with the 41,000 period, 41,000 years period. And the last one is the precession, the wobbling, wobbling of the Earth's that's called a precession, and that also changes. That is associated with the 21,000 years period. So this kind of orbital variations we call this Milankovitch oscillations, orbital variations, and that is very well superimposed in the past, the climate change and the glacial epochs, the glacial ice ages. If you look at it, it has been very well superimposed on this orbital variation, and that indeed gives us the proof indeed for what exactly has happened in the past and how this orbital variation also has influenced the climate. The next one is the tectonic processes, the land, the masses, even the movement of the plates, the lithospheric plates, that also can cause a change in the climate. The last one is the volcanic eruptions. And in the recent past, if you see the Mount Pinatubo 1993, and this volcanic eruption also, that releases a lot of gases into the atmosphere, the sulfur dioxide rich in this gases, volcanic gases, and that also can cause a change in the climate. And since this Mount Pinatubo is an example which we have analyzed, and we have got a lot of inputs, because volcanic eruption in the past also has contributed to climate change. So many volcanic eruption has taken place in the past, because volcanic degassing is an important process in the evolution of atmosphere. So this is how the natural drivers of climate change is important. Now, yes, natural reasons are there that has caused a change in climate, but now we are into an era of Anthropocene. Yes, every one of us is using the word Anthropocene. The simple reason is that the actions, the activities, the use and abuse of all possible resources on the earth's surface, that has been highly manipulated, highly influenced by the social animal, the human beings, and that is how the anthropogenic activity also has caused a lot of change in the environment, the global landscape, and this anthropogenic drivers also has contributed to climate change. Now we have to understand that the climate change what we are talking about right now is anthropogenic induced climate change, and we call it as modern climate change because the human beings are responsible for causing climate change. That you can see for yourself is that since the Industrial Revolution, look at the concentration of the trace gases, greenhouse gases, atmospheric composition that has changed. May it be the carbon dioxide, the nitrous oxide, the methane, it has changed tremendously. For instance, the carbon dioxide, the concentration then before industrialization, it was around 280 parts per million. Now it has crossed 412 parts per million. So this change, this increase is because of human activity. It's because of industrialization. It's because of change in the land use pattern, agricultural activity, or because of the use of fossil fuels. These are all the things that has pumped the greenhouse gases into the atmosphere. So then for next concentration as far as the greenhouse gases is concerned, methane. The concentration now it's 1800 parts per billion. Look at the concentration. Then it was very less before industrialization, and this increase in the methane concentration, 1800 parts per billion is a present concentration, and this is because of what? Because of human activity, because of agricultural activity, because as far as the methane emission is concerned, agriculture is a very important activity that has caused increase in the methane concentration in the atmosphere. Then as far as agriculture is concerned, one important gas is also responsible, the nitrification process, the nitrogen fertilizers we are applying it, and this is also releasing another important gas that's called nitrous oxide. These are the three important gases, that's carbon dioxide, the methane and nitrous oxide. There are many other gases also which are short-lived, nevertheless they are very important, they are climate pollutants. But as far as the examples, as far as the indicators are concerned, whether human beings have caused the change or not. So these are the atmospheric composition is definitely the data that shows that definitely human beings are responsible for causing a change in the atmospheric, the greenhouse gases. Next one is the land use changes. When you see the 40% of the land use is under agriculture, and this is because of human activity. Agriculture is also contributes a lot of the gases into the atmosphere, particularly I said the carbon dioxide, because of all activities, starting from plowing till all your farm activities, or somewhere or other it consumes energy, so it releases greenhouse gases, particularly the carbon dioxide. Even the plowing of the soil also releases carbon dioxide. And the methane, that's another important gas, because the biomass is rich in carbon, and under anaerobic condition that anaerobic decomposition, that releases methane. So agriculture mainly contributes the carbon dioxide, the methane and nitrous oxide, and that way land use changes also contributes to climate change. Land use change not only agriculture, it can be on the the urban land ecosystem also. The urban ecosystem, the coastal ecosystem, everywhere there's a lot of change in the land use, and that land use is also somewhere or other they are resulting in change in climate. And the last one is, yes, it is all related actually, the aerosol level and aerosol concentration, that is also having an the main driver is the human activity, and again the fossil fuel use. So these are the three important things as far as the anthropogenic drivers are concerned. And to put it in a proper perspective, that we have seen in this session what is exactly the climate system, what are the physical, chemical, biological interaction that is taking place in the climate system. And we have seen the budget, the global energy budget also, that gives us a bird's eye view of what exactly is happening in the climate system and why the way it is. That means that the temperature is 15 degrees centigrade. Why it is 15 degrees centigrade average temperature? That you can understand looking at the Earth I'm talking about the global energy budget. Thereafter, we have seen the drivers, the natural drivers, the natural causes of climate change, and now we have seen the anthropogenic drivers. So in this session, we have seen how the human activities, the rapidity, how they have caused a change in the climate, that we have seen it, and that you, for yourself, you see in the last century the temperature increases to the tune of 1 degree centigrade. Last century the global average temperature, it has increased to 1 degree centigrade, and it has been projected that by the year 2030 to 2050, if the trend continues, the temperature will be increasing much further, it will be crossing perhaps 4.5 degrees centigrade. So this is a very important thing that we have seen in the last century. And look at the data of the sea level rise. Yes, sea level rise has increased in the last century because of the human activity to the tune of 0.19 meters, 19 centimeter. That sea level rise is because of what? Human activity. That is also an indicator of climate change. And another example, as far as the indicator is concerned, let me put it in a final thing, is that because of the increase in the carbon dioxide concentration, where is that carbon dioxide goes? From the atmosphere, the most of the carbon dioxide from the atmosphere is being absorbed by the ocean body. And because of the absorption of carbon dioxide into the ocean body, what happened? The process called acidification take place. And this acidification is also an indicator of climate change. It's also an indicator of what? Increase in the carbon dioxide concentration in the atmosphere. And the pH value of ocean body, it is reduced to a tune of 0.1 pH, but 0.1 pH is also indeed a very big amount as far as the change in the ocean body is concerned, extent of the ocean body is concerned, because that can have a lot of repercussion as far as the thermohaline circulation and many other processes that is taking place. The ocean body impacts are much higher. So that's it. We have seen today a very important session on climate system. Thank you.